Bonjour. Welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am Bronwyn Slate. If you'd like to participate live, you are welcome to call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM or through the television at Bell Express View channel 972. You are always welcome to join me through Zoom. The link is available through me, your teacher, and also your DEC. Our schedule is such that we have classes Monday through Thursday from 11 till 12 in the morning, and we are now in week 4 of our 9-week course. A reminder of what work to submit. Support questions, those marked with the pencil icon, are not for marking. They are just for practice to get you comfortable with the skills. So you decide which ones and how many you would like to do. And if you're understanding a concept, feel free to skip questions. If you need more practice, let me know and I can send you some. The answers are in the back of the booklet, so please check your work to make sure you're on the right track. However, there are mistakes in the answers. We've found a few already, and you may find some more. So let me know if anything isn't making sense, and we can check to see if that's just an error. Don't believe that they're definitely right and you're wrong. Mistakes definitely have happened. The key questions, the ones marked with the key icon, are the questions to submit for me to grade. So please do all of them. Show all of your work and your steps and your thinking. This way I can give you credit for all of your understanding. If you make an error at one point and you only give me the answer, then I don't know what you do understand and where you made a mistake. So please show all of your work. How to submit your work for marking. There are 3 methods. The first is to scan and send your work in electronically. You can scan your completed work through the iPhone's Notes app or the Google Android Drive, the Google Drive app on Android devices. Then you can email it to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca, or you can send it to me through Facebook Messenger at bslatewahsa. Second method is to drop it off in Sioux Lookout. We have an outdoor mailbox at our address 74 Front Street at entrance. We're the big red building next to the post office, and there's a small white mailbox next to our side door. We are currently working remotely, so it may take me a day or 2 to get your work, but I'll get it and then get it back to you as soon as possible. Method 3 is to hand it into your DEC. Your DEC can then either send it through the Express or fax it to 807-737-1732 or toll-free fax 1-800-463-7852. If you have any questions or concerns, please contact me. This is what I'm here for. This is my job. This is what I like to do. So you can email me at bronwyn.slate, which is spelled BRONWYN.SLATE@nnec.on.ca. You can message me on Facebook at bslatewahsa. You can call and leave a message for me at the main office, and they'll get the message to me at 807-737-1488 or toll free 1-800-667-3703. My office hours are currently Monday through Friday, 8 a.m. to 2 p.m. and I'll get back to you as soon as I can. Connecting with me through social media, both my Facebook and my YouTube channel are called bslatewahsa. If you can friend me on Facebook and subscribe to my YouTube channel, all of our radio Zoom classes are posted shortly after airing, as well as I have other videos that explain common errors and confusing concepts. So that can be really useful to go there first if you're struggling with an idea. Math is a very visual subject. So being able to tap into either the live Zoom videos or watching the replays on YouTube is really going to set you up for the most success. Just listening to what I'm saying is going to be really, really challenging. So I really strongly advise you to watch the videos. Then you can slow things down. You can pause things, stop them as you go, so that it can really make sense for you. All right, we're on day 13. of our course, and we are diving into lesson 9, loans and RRSPs today. Our learning goals are such that at the end of this lesson, you can say, I will be able to calculate the cost of borrowing money to buy an expensive item. And 2, I will understand the advantages of early deposits to long-term savings plans. Success criteria. I know I've met the learning goals because 1, I can calculate how much it costs me to borrow money, and 2, I can show the calculations that show the advantages of depositing money early into a long-term savings account. All right, so let's activate our brain with some mental math to get us diving back into doing some math. Mad minutes are something many of us experienced in elementary school, and they were not positive experience. They were drill and kill. They didn't teach us any skills. They didn't get us more comfortable with numbers. And that is something that really set many of us on a path that was for a negative math experience. So instead of doing those sorts of things, we are using strategies to get comfortable with number and being comfortable with arithmetic. So today's question is 700 divided by 8, and we're going to use proportional reasoning. So instead of using long division, we're going to, which is pretty much the only tool that I was ever given to do division, we're going to use proportional reasoning, which is the idea that things are in proportion. So, so let's look at the examples to understand what that means. So 700 divided by 8. I don't know what that is, but I know that I can cut 700 in half to be 350, and I can cut 8 in half to be 4. With proportional reasoning, I know that 700 divided by 8 is the same thing as 350 divided by 4, because really I've just divided my things into groups already. And now I'm dealing with a smaller amount of groups, but they're still in proportion. They're still the same. If I was to divide 700 into sevens and say it was 100, then I'd have to divide 8 by sevens in order to get a seventh. So that doesn't help me. That doesn't make my life easier. Okay, so I still don't know what 350 divided by 4 is, but I could think of, well, I know what half of 4 is 2. So if I continue with this idea of proportional, that if I divide my one part by 2, cut it in half, I need to divide the other part and cut it in half. So 350 divided by 2. Well, 300 cut in half is 150, and 50 cut in half is 25. So 350 cut in half is going to be 175, 50 plus 25. Okay. So then if I were to cut my 2 in half to get to 1, I just need to cut 175 in half. Okay. Well, 175, so 100 is cut in half is 50, and 75 cut in half isn't super easy, but so I'm just going to keep track it over here to help us. So 50 cut or 100 cut in half is 50. Then I'm going to say 70 cut in half is 35. And then 5 cut in half is 250. So if I'm going to do that all together, 175 cut in half is going to be 87.5. So sometimes you need to break things up in different ways. So 87.5 divided by 1, well, anything divided by 1 is just the same. So 87.5 divided by 1 is 87.5. And because we've done this all in proportions, that this is all the same, I've just broken it up into smaller groups in the same relationship. 700 divided by 8 is 87.5. So play around with that strategy a little bit to see if that is helpful for you. Basically, these strategies are just trying to give you more options for what could be helpful for you. All right, mine's on. Let's engage in some prior learning to dive into our new concept today. So we need to talk about some financial vocabulary. We're looking more at money today with loans and with RRSPs, which are definitely things that are going to show up in your life, most likely. So knowing what a loan is when you borrow from a person or a business, you're borrowing money, and therefore you pay money, the interest, to them for letting you borrow money. That's what it all is. An investment is basically you're lending your money to a person or a business, and they give you money, interest to you for letting them borrow that money. It's not often how we think about it, but that's really what an investment is that you're giving them money, they can do something with it, and then they're giving you back your money, and with interest on it, paying you for letting them have your money for a period of time. All right, again, we're going to have to think about compounding periods, which we did with our previous lessons, but we have a couple new ones that we haven't talked about before. So annually is 1, semi-annually is 2, quarterly is 4, monthly means 12, right? All of those words mean those number of periods, compounding periods per year. A new one is we have that is semi-monthly. So a semi-monthly means that it is twice a month. And so there's 24 compounding periods per year. Had before, which was 52 compounding periods per year. But now we have bi-weekly, which is every 2 weeks, which is 26 compounding periods per year. People often get semi-monthly and bi-weekly mixed up because they're so close, but semi-monthly is twice a month. There's 12 months. So therefore it is 12 times 2 gives us 24. Bi-weekly is every 2 weeks, which every 2 weeks is 52 weeks divided by 2 gives us 26. So that's one to be really careful with. And then finally we had daily, which is 365. So being comfortable with that language and the numbers that those language represents is really important so that you know what you're doing, you know how you're compounding. All right, active learning. Let's dive into our new concepts today. So always answering the very violent question, when will I use this in real life? Well, we're trying to think critically with money. Money is something that all of us have to deal with. There are many ways that businesses and companies bank on you not understanding and being comfortable with numbers, and therefore they can make more money off of us because we're not educated about it and we're not comfortable with figuring it out, and we just trust them, which I know that I've definitely been scammed because of those sorts of things, and I'm sure other folks have experienced that as well. So being comfortable and thinking about your numbers critically is really going to help you in the long run. All right, first we're going to look at loans. This is on page 21 of your IL book. So a loan, again, when you take out a loan, you must repay the loan plus any interest that has been charged. So the interest is the cost of borrowing the money. Most commonly, loan payments are calculated and given a regular payment per month. This monthly payment covers paying some of the principal and some of the interest. For loan payments, we use what's called the present value of an annuity formula. I have a hard time saying that word. So annuity is a fixed sum of money paid at regular intervals. And this is really key to what we're doing. How it's different is that we're making a payment at the same time consistently over some period of time. So we're going to look at the present value of an annuity formula today. First, this is really, really poorly written in your booklet. The formatting has been all glitched and messed up, and I wasn't able to fix it before the booklets were sent out to you. So I would say write in your booklet, rewrite it according to what's written down on what I'm going to just walk through right now, or look it up if you're just listening to it, or on the video, pause and rewrite it in your booklet. I'll fix it for future, but I can't fix your booklets right now. So the present value of an annuity formula is PV equals R, then open a square bracket, 1 takeaway, then open a round bracket, 1 plus I, close your round bracket, to the exponent negative n, and then close your square bracket, all over I. So if you're just listening to this, it might be worthwhile to touch base with me or to look it up, because it's possibly hard to make sure that you're getting that right, which is really important. So then what do all those variables mean? So PV equals the amount that must be invested now in dollars, or how much it's worth now. The R is for the regular payment. It's a capital R is what we use. The I, which is a small I, is the interest rate, is always expressed as a decimal per compounding period. So this is equal to the interest rate as a decimal divided by the number of interest periods in 1 year. This is why those compounding periods are really important to know. And then N is a number of payments made. So that might, in your situation, you might just know how many payments you're making, or you might need to do the number of payments per year times the number of years. All right, so let's look at a situation so that we can break that up a little bit more. So a set of winter tires can be purchased for no money down and 12 easy payments of $89.55. Interest is compounded monthly at 15.7% per year. How much do I end up paying for tires for the total of the tires? Everybody's heard that sort of ad, no money down and 12 easy payments, right? So this is how it works, how those payments are calculated. So because it says payments in our question, we know that we're using an annuity, we're making payments. We can't use just our compounding or our simple interest formulas because we're making payments. That's how it's different. So we need to use our PV equals R times 1 minus 1 plus I to the exponent negative n all divided by I. So we write down our formula and then we figure out what our variables are from our question. Sorry, my computer is giving me issues. Okay, so in our question, it says 12 easy payments. That is our N, the number of payments. And R is $89.55 because that's how much our payments are. Our I is 15.7%, so 0.157 divided by 12 because it's compounded monthly. And the question says, how much do I end up with? So that's our present value. That's what we're looking for. And that's how we figure out what our variables are. Then we substitute our variables into our formula. And if you're seeing this on the video, you can see that it really starts to get kind of confusing. So writing out carefully is really important. There's lots of details. So our present value is what we're looking for is equal to 89.55 times 1, take away, open a bracket, 1 plus 0.157 divided by 12, close your bracket, all to the exponent negative 12, and close your square brackets, divided by 0.157 divided by 12. You can do the I division first and then just put in your decimal, but remember every time that you round off a decimal, you're losing information. And so you're not going to have as exact an answer. So if you can leave it in a fraction, that's going to get you a more precise answer. So then my next step, I've done the division just so you can see. So PV is equal to 89.55 times 1, take away 1 plus 0.01308, all to the exponent negative 12, close your bracket, divided by 0.01308. So that's what it would look like if you did the decimal. Again, I strongly advise you, if you can, just leave it in the fraction form and then let the calculator hold that information. But if you need to do it, that's fine to write out the decimal. Try to give yourself 5 or 6 decimal points to keep it as close as possible. Also a great tool is the Desmos scientific calculator, which you can use online. I'll link it in the show notes as always, which then you can put all of this information in and you can see it keeps it, that it shows you all the information that you're writing, so you can then make sure that everything is lining up the way that you're expecting it to, and that you're not just making a calculator error, because sometimes your calculator makes mistakes because it is understanding it differently than you're intending it to. So the scientific calculator for Desmos means that you can see exactly what's going on, and if you need to change something, it's pretty straightforward to change it. All right, so then you do all that calculation, and that gets that PV equals 988.53. So what does that number even mean? At this point, I forgot what the question asks. So I go back to the question. The question said, how much do I end up paying in total for the tires? So therefore, it would end up costing me $988.53 for a set of winter tires. And then I know what that money was worth. or what I was getting for that money. So the next thing that we're trying to figure out is if we're finding our payment amount. So not how much we paid in total, but our actual payment amount. So this formula, we're going to figure out how we figure out what that formula is. So we start with our annuity formula, and we're going to rearrange it. So how we do that is that we have, so our original formula was PV equals R times 1 minus 1 plus I, all to the exponent negative n, close your square bracket, all over I. So we're trying to isolate for R. That's what our payment is, right? So to do that, we're going to multiply both sides by I in order to cancel off I on our side that has the R. We're just doing algebra. So we end up with PVI equals R times 1 minus 1 plus I, all to the exponent negative n. So then we want to divide that side by 1 minus 1 plus I to the exponent negative n. We do it on both sides. In order to cancel it off on the side with the R, we end up with it on the side, the other side. So therefore we get that R equals PVI times I divided by 1 minus 1 plus I, all to the exponent negative n. This lesson has a lot of formulas in it, and we're going to go through how you know which formula to use later. You do not need to memorize these formulas. I do not have these formulas memorized. You're going to look them up. When we have your exam, I will give you the formulas, and you will need to know how to use them and how to apply them in the right situations, but you do not need to have them memorized, and you do not need to be able to change one into the other. This is just showing you how that happens, how they're connected. Okay, so let's do an example situation of finding what the payment would be. So calculate the monthly payment of a $15,000 loan at an 8% interest rate, compounded monthly over 5 years. So again, we're looking for a payment, so we know that we're using our annuity formulas. So we have R, because we're looking for our monthly payment, equals PV times I over 1 minus 1 plus I to the exponent negative n. And that's what we're looking for. So we need to find out all of our pieces. So our payment amount is what we're looking for. So our R we don't know, sorry. Our $15,000 is our present value. That's how much we're borrowing. It is 8% compounded monthly, so 0.08 divided by 12. And our N is 5 years compounded monthly, because we're doing monthly payments, is 5 times 12, which is 60. So our total number of payments is 60. So then we input our numbers all back into our formula. So we have R equals 15,000 times 0.08 divided by 12, all divided by 1 minus 1 plus 0.08 divided by 12. Close your bracket to the exponent of negative 60 and close your square bracket. Again, you can do it as a decimal, or you can just do it as a fraction. So that if you translate that into a decimal, you're going to end up with R equals 15,000 times 0.00667 divided by 1 minus 1 plus 0.00667 to the exponent negative 60, which is equal to 304.17. So we have to remember, what are we asking? So the monthly payment would be $304.17. So then to calculate the total interest paid at the term of this payment that we just found. So if we have a question that's asking us how much interest we paid in total for that loan, we need our present value, our payment value, and how many payments we made. So the total interest is going to be the total number of payments, take away the present value, take away the amount that we borrowed. So the total number of payments is equal to your R times N, right? Your number of payments times your payment. So we end up having I, your interest, is equal to 304.17 times 60. All that take away 15,000. So we have 18,250.20. Take away 15,000. which is equal to your interest, is $3,250.20. So the total interest you paid to borrow that loan for and pay it back over 5 years was $3,250.20. That's the extra money that you paid just to be able to borrow and take that loan to pay it back. All right, so now you can pause the video if you are watching the video to do some support questions on page 23, questions 1 through 5. That's the section on loans that we just went through. All right, now we're going to look into what RRSPs are and how those are calculated. So this is on page 23 of your IL book. So an RRSP stands for Registered Retirement Savings Plan. Many of us have probably heard about them, but don't necessarily know too much about them. So this is a saving plan for people who are earning an income. They contribute funds and interests are earned. None of this is taxed until the money is withdrawn. So if you put money in and you earn interest, that money you don't get taxed on until you take the money out. Once you retire, you can set up a system where you can withdraw regular equal amounts from your RRSP. You can take all of it at once, but often it makes most sense to take payments out so that you have an equal, you don't just have all of your money at once, but you get to decide. So now we're going to figure out how we calculate these things. So if you're planning to contribute to an RRSP, we use the annuity formula. Again, this is really poorly typed out in your book, so pay attention here and rewrite it in your book if you can. So we have two different formulas. We have our A equals R square bracket, round bracket, 1 plus I, close your round bracket to the exponent n, minus 1, close your square bracket, all divided by I. So that is your annuity formula if you're looking for your total value, and you know your payment value. If you know your total value and you're looking for your payment, you use R equals A times I, all divided by square bracket, round bracket, 1 plus I, close your round bracket to the exponent n, minus 1, close your square bracket. So again, these letters mean the same thing. The A is your amount of your annuity in dollars, your R is your regular payment, your I is your interest rate as a decimal divided by your number of interest periods or compounding periods per year. Your N is your number of contributions made, which is the number of contributions per year times the number of years, if you don't know how many you made in total. These formulas are very similar, but significantly different in terms of, they look similar, but it matters in terms of when you're subtracting, when you're adding. If you have negative exponents, you don't have a negative exponent, so you have to be really careful and know which one you need to use. Again, we're going to go over that at the end. All right, so let's look at a question. So the example is, how much of an RRSP is worth when we're retiring? So let's look at this question and figure out how it helps us. Jay began making monthly contributions to his RRSP at the age of 31. His average monthly contribution, starting 1 month after his 31st birthday, was $200, and his RRSP earned interest at an average rate of 6.8% compounded monthly. Jay stopped making contributions when he retired at the age of 65 and started to withdraw a pension from his RRSP. So part A is determine how much Jay's RRSP is on his 65th birthday. So if he's putting in $200 every month from the age of 31 to 65, how much money does he end up having at the end of on his 65th birthday is what this question is asking. So we are looking for the monthly contributions to his RRSP, means that we know that we need to use our annuity formulas. And because we know that we're trying to find the total amount, we're going to use the A equals R times 1 plus I to the exponent n minus 1 all over I. That's how much we're trying to find out, how much in total. So we're looking for A. So R is 200 because that's how much he made his monthly payments. I is 6.8% compounded monthly, so 0.068 divided by 12. And N is our number of payments times 12 because they're monthly payments. So the number of years is 65 take away 31, right? Because we know how much when he started when he was 31, he ended when he was 65. So that's going to be 34 years times 12, which is 408 payments in total. So it's asking us to determine the amount of J's RRSP. So that's the A, that's what we're looking for. So now that we know what our variables are, we're going to put them into our formula and get A equals 200 times 1 plus 0.068 divided by 12 to the exponent 34 times 12, which is our n, so which is 408, minus 1 divided by 0.068 divided by 12. So that is equal to A equals 200 times 1 plus 567, all to the exponent 408 minus 1 divided by 0.00567, which means that our annuity is $318,668.14. That number is if you didn't round off anything, you put your exact values in when you did the fraction in your division. If you were to round it off and use a decimal amount, then you end up with $318,959.51. I will accept both these answers if you, as long as I'm seeing your work, then I can understand what you were doing. If you just give me a number and I have no idea where it's coming from, it's not even close, then I can't accept it as a correct value. But this is what I mean by your answers might be slightly different based on if you round, how much you round, or not. So therefore, on Jay's 65th birthday, his RSP would be worth $318,668.14. That's how much his RSP would be. He could take it all out, or he could take it out of payments. So from there, how do we figure out what our monthly payments would be? So if we wanted to determine the monthly pension, we're going to use that present value of the annuity formula. Again, this is poorly typed in your book. So this is the same thing that we were doing at first, because this is the payments that are coming out, right? So we're not putting payments in, we're taking payments out. So we're still using PV equals R times 1 minus 1 plus I to the exponent negative n divided by I, or R equals PV times I divided by 1 minus 1 plus I to the exponent negative n. Our variables all mean the exact same things that they've been meaning so far. Nothing is different. It's just how we are calculating. So if Jay wants to know how much he's going to be able to take out, so he decides to reinvest the total amount of his RSP to provide annuity for his monthly income during his retirement. Suppose Jay was able to obtain the same average interest rate and chose a 20-year term over his annuity. What monthly pension could he withdraw for the next 20 years? So again, we're looking for an RSP and we're looking for monthly income. So we're trying to get monthly payments. So that means that we know that our formula is R equals PV times I divided by 1 minus 1 plus I, all to the exponent negative n. We know the total amount, right? We've calculated the total amount previously. So that's $318,668.14. The interest rate is the same as before, so that was 6.8%, so 0.068 divided by 12, because it's compounded monthly. And our N is monthly payments for 20 years. So 20 times 12 equals 240. That's how many payments he's hoping to get, and how much money will he get for each of those payments for each month. Looking for the monthly pension, so that's our R, we're looking for the payment. So we put that into our formula. R equals $318,668.14 times 0.068 divided by 12, all divided by 1 minus, open your bracket, 1 plus 0.068 divided by 12, close your bracket, to the exponent negative 240. So that's what your decimals would look like, which means like a total of your payment would be $2,432.52 per month. And then I've also have written on the screen the rounded values if you were to do the rounding. So Therefore, Jay would receive a monthly pension of $2,432.52. So for another 20 years, he would get that much money every month because of the investment that he made. So until from 65 to 85, he would get that amount. All right, so now you can pause the video and do support questions if you'd like. On page 26, these questions 6 and 7 are what related to the RRSP questions. So let's consolidate what we learned. We learned a lot, and it can be confusing because it's really similar but different. So we're going to look at how we can figure out which formula we need to in which situation. So lesson 9 highlights for loans and RRSPs. So loans, remember, are money that you borrow that is paid back through equal payments over a set period of time, including the interest. Payments are calculated according to how much we want to borrow. Right, so we can say we want to borrow $15,000, we want to borrow $60,000, and then we figure out how much our payments are, or how much we can borrow is calculated according to the payment we can afford. So it can be like, I can borrow, the bank where you're borrowing from says you can afford a $300 payment a month, you can afford $700 payment a month. That's going to be able to calculate how much money you can borrow in total. That's how like mortgages and things like that are calculated, like when you get pre-approved. So then RRSPs is a saving plan for people who earn an income. You can get the regular payments, you can reinvest it and get regular payments. And we know that if you invest early, you're going to earn more in the long run, right? Because if you put in more money, you put in money longer. So Jay had it for 34 years when he started at 31, but had he started at 21 and he'd invested for another 10 years, that would have meant that he would have earned a lot more interest and had a lot more money at the end. So if you can invest early, that's going to help you in the longer run. But even if you can't, doing it when you can is going to be helpful. So success criteria 1 is I can calculate how much it costs me to borrow money. So that's calculating the interest, how much it's going to cost you. And success criteria 2 is I can show with calculations the advantage of depositing money early into the long-term savings account. Right, so that's what we just talked about in terms of the earlier you invest, the more money you're going to have in the long run. Okay, so the most important question really for this one for me was, how do I know which equation to use? So if the question includes one total amount invested or borrowed at simple interest, which we didn't talk about today, we're going to use I equals PRT. So if your question says simple interest, we use I equals PRT, which was from lesson 6. If our question includes one total amount invested or borrowed with compound interest, we use A equals P times 1 plus R over N all to the exponent NT. Again, this was our compounding interest. So both these ones are, we have one amount that we're investing, borrowing, and then we have a simple interest or compound interest. That's how we know that we're using those formulas. So then if the question includes a loan with payments, it might say compounded, it might not, and you're looking for the total amount, then you use PV equals R times 1 minus 1 plus I, all to the exponent negative N over I. If you have a loan with payments, and you're looking for the payment amount, then you use R equals PVI divided by 1 minus 1 plus I to the exponent negative N, and that will give you your payment amount. Okay, so we're halfway through what we've explained. If we're contributing to an RRSP and you're looking for the final amount, then we have A equals R times 1 plus I to the exponent N minus 1, all divided by I. If you're contributing to an RRSP and you're looking for the payment amount, so how much you should contribute, then you have R equals A times I divided by 1 plus I, all to the exponent negative N minus 1. If you're receiving a monthly pension from an RRSP and looking for the starting amount, so if you know that you're getting this much of a payment, how much do you have to start with? So you have your PV equals R times 1 minus 1 plus I, all to the exponent negative N over I. or if you're receiving a monthly pension from an RRSP and looking for the payment amount. So you know how much of an RRSP you have, and you're trying to figure out how much payment you're going to get. You use R equals PV times I over 1 minus 1 plus I, all to the exponent negative n. So these two slides I've printed off for myself just to review, to have on hand, because I'm not going to remember which is which. So taking screenshots or printing off, these might be really useful to help you remember, figure out which ones you need to use. Again, you don't need to memorize these formulas. It's not something that makes sense to use your brain space for. Be able to apply them, but you don't have to memorize them. I'll give them to you for your exam. You can always look them up if you need to in life. So let's try to do a few questions to figure out what it is that, how we dive into a question. Let's do some practice. So Celie recently graduated from college and owes $16,000 on a student loan that he must begin to repay. Payments are to be made at the end of each month for the next 2.5 years. Interest is calculated at 9% per year, compounded monthly. Determine the amount of each payment. So again, I don't have this memorized, but I know that I'm looking for the amount of the payment. So I'm looking for that R, and I know how much I borrowed. So I'm not talking, this is a loan, and I'm looking for R. So I know that I'm going to use R equals PV times I divided by 1 minus 1 plus I, all to the exponent negative n. And I had to look up what the formula was, or I had it come up on this slide because I wasn't going to just remember what it was. But I am going to, so now I'm going to figure out what I know and go from there. So R, my payment is what I'm looking for. My PV is equal to 16,000 because that's how much I borrowed from the loan. My I is equal to 0.09 because it's 9% divided by 12. It's compounded monthly. And my N is equal to 2.5 because it's 2.5 years times 12, which 2.5 years times 12 is 24 plus 6 is 30. So that's 30 payments. Okay, so then I'm going to put my values that I figured out into my formula. So I have R equals 16,000 times 0.09 over 12, all divided by 1 take away 1 plus 0.09 divided by 12, all to the exponent negative 30. You can see it gets messy quickly. So 16,000 times 0.09 divided by 12 equal to 120. I'm going to calculate 1 plus 0.09 divided by 12. That's going to be to the exponent negative 30. And then I'm going to do 1 take away that. 1 take away. And I'm just doing this on my calculator. And I get, so that is 0.2008. So I have 120 divided by 0.2008 equals $597.61. So I did round some places and other places I didn't round. So this number, if you did it follow along, you might not get exactly the same thing, but you should get something roughly similar. Again, this is why it's really, really important to show your work, because then I can see, oh, you probably just rounded from here to here. Therefore, you're doing the right thing. It's just a calculation that is slightly different than what I did. Or using the Desmos Desmos scientific calculator, then you're able to really easily put in all the values and it calculates it all without doing any rounding. So monthly payments, make sure we know what we're answering. monthly payments are $597.61. Okay, so now it's saying, our question B is calculate the total amount needed to repay the loan. So how much does Sealy pay overall? So our payment amount from part one was $597.57. I think if I rounded it, so I think that gives a more precise number. So we're going to do that. Sealy paid that times 30 times, right? Because they made 30 payments of that. So $597.57 times 30 is equal to $17,927.10. So calculate the total amount of interest paid. So the total amount of interest is going to be the total paid, which is $17,927.10. Take away the total borrowed, which was $16,000. So that means that it's going to be $1,927.10 is how much. So the total interest paid is $1,927.10. And there we go. So sometimes you need to, these sorts of questions, you have knowing the information from the prior question is how you answer this, the next question. So when I'm marking, if you made a mistake somewhere early on, but continue moving on in the correct way. So if you calculated you made a mistake calculating your payment, but then you properly calculate the total amount that you need to pay and the total interest you need to pay based on that mistake, then I'll give you full marks for this because you understand what you're doing. Even if your numbers are technically wrong, you understand what you're doing and you lose a mark or whatever from where you actually made the mistake. But it's about understanding opposed to exact numbers. That's what's the important thing because that's what you're going to apply. Okay, question 2. Suppose you have an RRSP of $50,000 and you want to purchase an annuity that pays out for the next 15 years. So you've already put your money into your RRSP and you have $50,000 now, and you're trying to figure out how much you can take. I think you're going to try to figure out how much you're going to take out. So the interest rate is 8% per annum per year, and the compounding period is flexible. You can choose monthly or annual payments and compounding. Determine the regular payment for each compounding period. So in this case, we're trying to figure out which situation is going to work best for us between these two options. So okay, so I have to look it up because I don't have it memorized. So we are trying to determine the payment for each compounding period when we are having RRSP. So we look at our list from slide 40 and we say, okay, we're receiving a monthly pension from an RRSP and we're looking for the payment amount. That means that we're using the formula R equals PVI divided by 1 minus 1 plus I all to the exponent negative n. Bottom part, we put in square brackets to make sure that our calculators do it properly. Okay, so for option A, plan A, we have monthly, and plan B, we're going to call it, we have annual payments, or annual compounding. So every year or every month. So our PV is 50,000. Our I is going to be 0.088%. So for the monthly, it's going to be divided by 12, whereas for the yearly, it's going to be 0.08 divided by 1 because just once a year. And then our N, so we want 15 years for a compounded plan A, where it's going to be monthly. We're going to times that by 12. So 15 times 12 180. So we're going to end up with 180 payments, whereas N in our plan B is going to be 15 times 1 because we're just getting 1 payment per year. And so then it's 15. So those are what our variables are for each of our situations. So now we need to plug it into our calculators, our formula, and go from there. So for monthly plan A, we called it, we have 50,000 times 0.08 divided by 12, all divided by 1 minus 1 plus 0.08 divided by 12, all to the exponent negative 180. Now I'm going to do this all in my calculator in one go, and hopefully I don't make any mistakes, which happens. Being really comfortable with your calculator is really important. I'm not super comfortable with my calculator because it's not the one that I grew up using, but I'm making do. So you're going to put all of those values in, using all of the parts that you have. And so for our monthly plan, we end up with a payment of $477.83. So then let's see what our payments would be for our annual plan. So we have R equals 50,000 times 0.08 divided by 1, all divided by 1, take away 1 plus 0.08 divided by 1 to the exponent negative 15. So again, I'm going to put this in my calculator and calculate it out. Using your brackets is really important when you're doing this on a calculator so that it applies the right things to the right spaces and does your order operations properly. So that payment is going to be $5,841.48. Obviously much larger because it is yearly opposed to monthly, but who knows if it's better. So determine the total amount received for each compounding period. So for our plan A, our payment is $477.83. And we had 180 of those payments. That's our monthly payment. When we had an annual, it was $5,841.48. And our N was 15 because we had 15 of those payments. So to figure the total that we would get for our monthly, we would have $477.83 times 180. So that means that we're getting $86,009.40, where our annual amount is $5,841.48 times 15. So our total is $87,622.20. So because we're reinvesting our money, we end up getting more than just the $50,000 that we started with. So we can figure out monthly, we would get a total of $86,009.40. If we did the annual option, we'd get $87,622.20. So which investment would you choose? Because I want more money than less money, would choose the annual compounding and payments because that gave me more money. And I want more money. So then I would just have to budget wisely. That's how you can do questions like that. All right. So we are at the end of our time today. As always, if you have any questions, please contact me. This is confusing stuff, so it's understandable if you have questions. It took me a lot of thinking when I was writing up this lesson. So please reach out if you need to. You can call and leave a message for me and I'll call you back at 807-737-1488 or 1-800-667-3703. You can email me at bronwyn.slate@nnec.on.ca or Facebook me at bslatewasa. Check me out on YouTube at bslatewasa and you can watch this video again, which you may need to do. I hope you have a lovely day. Mwich.